Let's look at an example of converting a complex number from Cartesian form to polar form. Suppose we have the complex number z is equal to 1 plus square root of 3 times j. So this complex number is given in the Cartesian form, right? The real part is 1 and the imaginary part is square root of 3. And we're asked to find r and theta. And we know that r is the square root of a squared plus b squared. So a is 1 in this case, and b is square root of 3, so b squared is 3. So the magnitude of this complex number is 2. And to find the angle, theta, what we said was that theta should be tan of b over a, which is square root of 3 over 1. So this tells us that theta is the inverse tangent of square root of 3. So the inverse tangent of square root of 3, if you plug that into your calculator, you will get an answer which says it's 60 degrees or pi over 3. And indeed, that is the correct answer in this case because this angle is 60 degrees. However, let's take a slightly different example. Suppose the complex number is the negative of this complex number given by negative 1 minus square root of 3 times j. Now, in this case, if we were to compute the r and theta, notice that r would be exactly the same. So maybe I'll call this complex number as z2. So let's call this as z1, and let's call this as r1 and theta 1. So r2 is also equal to 2. But when you try to compute theta 2, you see that theta 2, if you simply use the formula, you're going to get tan of negative 3 or negative square root of 3 divided by negative 1, which of course is the same as tan of square root of 3. So now you see the problem, right? So if you simply plug this into your calculator and you try to compute the angle as the inverse tangent of square root of 3, you're going to get pi over 3, but that's clearly not this angle. And the reason you get into this problem is because tan of theta is the same as tan of pi plus theta, or tan of theta minus pi. And so what we need to do is to realize that your calculators are typically going to give you values only between 0 and pi over 2 or 0 and negative pi over 2. So they're going to give you values between negative pi over 2 and positive pi over 2. And what we need to do is we need to either subtract a pi in this case or add a pi in other cases to make sure that we end up in the right quadrant. So, and the easy way to do that is if you think about the sign of the real part. So these calculators are typically going to give you only angles that correspond to the complex number lying either in this quadrant or in this quadrant. But you know by looking at the sign of the real part that the complex number is going to lie to the left of this y-axis. So what that means is you need to subtract pi from this, and when you subtract pi, you will get negative 2 pi over 3. So this is not quite right. Rather, theta 2 is the inverse tangent of square root of 3 minus pi, which will be 2 pi over 3. Okay. Now, when would you have to add a plus pi? Now, you could have added a plus pi to this, and you would get the correct answer, because pi plus pi over 3 would be 4 pi over 3. And 4 pi over 3 is the same. I'm sorry, this is negative 2 pi over 3. So 4 pi over 3 is the same as negative 2 pi over 3. And by convention, we want angles to be between negative pi and positive pi, so we want the negative 2 pi over 3. Okay. Let me quickly work out one more example. So let's work out one more example where we have z1 is 1 minus j. So if we were to convert z1 to polar form, we would get r1 to be the square root of 1 squared plus 1 squared. So you would get r1 to be square root of 2. And to compute the angle theta 1, you would see that this is the inverse tangent of 1 over negative 1, which when you plug into your calculator, you might get negative pi over 4, which is indeed the correct answer. Now, however, if you try to repeat the calculation for z2, which is the negative of this complex number, you would have no problem computing r2, which is still square root of 2. But what should be the angle theta 2? So you notice that this complex number lies in the second quadrant. So the angle that we get should be something that's between pi over 2 and pi, right? So theta 2 should be, if you naively take the inverse tangent, you will again take inverse tangent of negative 1, which you will get negative pi over 4. But what you need to do is to add a pi. And that will give you 3 pi over 4. Again, notice that the real part is negative, so you know that you need to either add pi or subtract pi. You just need to add pi or subtract pi depending on which is going to put your angle between negative pi and positive pi. Okay, so the best sanity check in the end is to make sure that the angle that you get corresponds to the complex number in the correct quadrant. So you know by looking at these, the real and imaginary parts, just the sign of the real and imaginary parts, you know which quadrant this complex number has to lie in, right? We just need to make sure that the angle that you get correctly puts you in that quadrant. Now, if you use software packages to compute the angle or the phase, usually you will not have a problem. I've checked, like Python, for example. In Python, there is a command called numpy.angle of a complex number, and it will give you the correct answer. You would not have to do any correction for pi, but it's always good to know whether your software is doing the right thing or not.